And welcome back to Flexible Games, mod tutorial series for FortressCraft Evolved. Today we are going to look at UI feedback to the player. Now, somebody can look at your block in the game now that you have it in there. How do they know what's going on? Well, here is one way to do it. There's override right here. This public override string GetPopupText. This is an override, which means we are inheriting this function from our parent object, which is machine entity. This command, if you override it, you don't have to. If you do, this is called every frame. So just be aware that this is a UI thing, and it's called in every frame from probably from the Unity thread or whatever thread handles the UI. But I know it's called every single frame, so just be aware of that. Don't put anything too heavy in this GetPopupText. Now it returns a string. So when we go in here, you'll see this L string in here, which means local variable string. You can name it anything. So if we are not the linked center, so linked center does not equal null, which means we are the center. Okay, that's kind of a backwards way of doing it. So an alternative to this would be to put this whole block of text in an if statement that said, if, let's see, MB is center. So this whole block of text would go into this here, and it's the same thing. So what this is saying is if the link center has something in it, I want to return that link center's pop-up text. Okay, so like I said, only the center controls the block. So now that we're past that, let's go into how this processes. This string object is going to handle all of the text that comes down, and it's the bottom, sort of the bottom left corner when you're looking at a block, all the text that pops up there. So it changes every frame, so any values that change will change in real time. So here I have that I have a Boolean that says, is it melting down? And it can explode. So if both of those are true, I pop a warning up that says overheating, meltdown in. Then I have the timer. The toString N1 means it's going to be a number with one decimal point. So like 13.4, 13.1, stuff like that. And then we go down into power. So I get the current power. N0 means it's going to be a number with 0 decimal points. The power storage total, which is also a number. Then I go through and I see, are we a server? If we are, we have to process the hoppers. So if we don't have any hoppers, tell us that. If we do, tell us how many we're attached to. So if we're count is greater than 0, attached to that count hoppers. And here we have attached count equals 0, no attached hoppers. I'm not sure what the point of this code means, but I added this little line here that appends these. This /n is a new line because this is one contiguous block of text. /n is a new line. So I don't have one here, which means it will append onto this text up here. So the text in the game will read attached to 1 hoppers and 2, 1 power consumers, or whatever those numbers end up being. So it'll tell me how many hoppers it finds and how many power consumers it finds. Now, this is based on per face. So if you say build the reactor and then build the battery on top of the reactor, this will say 9 because there's 9 faces touching that battery. So just be aware that It's per face, not per object. Continuing on, we see that we have the same code down here, and then going further, I'm putting out the power per second, and basically the power per second is the current power per second. And I want to set the power per second at 0 if we're out of fuel, current time active equals 0, or we're full. So if we have no fuel, power per second equals 0. If we're full, power per second equals 0, because we're not generating power. I already have that code done to stop us from using up fuel or generating power when we're already full. So I just want to make sure those are done. So this tells me I'm generating this many power per second, and this tells me fuel time left and coolant left. And I use both timers with N1 for seconds. So these are independent. The coolant and the fuel are independent of one another. You can have fuel, but not coolant. And if you do, that doubles the power per second that you're outputting. But right now, the fuel time and the coolant time are both at 60 seconds. The timers on those are bound together. So you can set the active time to maybe 5 minutes if you want, 300 seconds. But the coolant will still be bound to the fuel time. So even if you wait, if you set it to 5 minutes, you put some fuel in there, it's gonna start powering at 50,000 power per second. But it's going to be overheating. So because you didn't put coolant in, it's going to double that to 100,000 power per second. Now, the second you put some coolant in, that's when that timer starts. So your fuel time left could be 2 minutes, but your coolant time could be 5 minutes. So those are not bound together. Now, I don't have any user interaction in this at all. There's no flags to count, no flags to edit variables. So let's take a look at my Excavator mod and scroll down here to look at the extensive pop-up text that's processed every time you look at it. So again, this is set. This is run every frame. So we're going in here, we're pulling in, making sure that we've got the excavator, we're looking at the excavator, and now I do these key down commands. So I bound this to Q, which is fire mode. So this change fire mode cycles the fire mode, as you go. It's just changes the fire mode to the next one, to the next one, to the next one. Now, here's where it gets a little funky. Because we have servers now, I had to go in and change this around to use servers. So here is how you do that. First of all, in your main registration function, you want to first create a new call. Now you're going to want a new object for this, which is my window. And the window derives from base machine window. Now this window is not actually a UI that pops up, although it can be that. So you can have your own UI. I'm choosing not to have a UI because everything is handled in the pop-up text. But this still has to be used in order to get network calls to work. So I have my window, my base machine window, and in here I have an update machine, which just does some basic stuff, not really used very much. But these calls here, alter height, alter radius, alter dig state, and alter drop state, those now come into play in my pop-up text. So the first thing I do is grab whether or not we are a server. If we are not, we just go ahead and print out the dig state. We convert the text into actual text. I could probably just do a 2-string on this, but I'm a little completionist when it comes to my UI. Okay, so the other thing we call here, if we're not the server, we call this window class alter dig state. We're sending it this. So if we look at alter dig state, we're sending it a copy, a reference to this object, to this excavator, and we're setting it the dig state, the new dig state that we just set, we're sending it to alter dig state. So if we look at the window, where did it go? Alter dig state, we need an excavator and we need the data. And in here I do a switch. Now there's a few different ways that I could do this. I could have sent it the enum of the dig state, but I was kind of learning as I coded this and I really wasn't sure how it worked. So in here we alter the dig state and we set in here using the machine the new dig state. We don't set it in here. We set it in here. And because we passed the machine in, this change will affect the machine that we just commanded. We mark it dirty, and we detect if we're not the server, network manager instance send interface command. This is what's really important. So we changed the dig state locally. That's essentially what we did. We altered the dig state, it changed the machine locally, but it didn't change it on the server. This is the command that sends it to the server right here. So this instance, we send interface command, flexible games, Mark II excavator window, alter dig state, which is this. We send it the data, which is the string. We don't send it anything, which is essentially the payload. We don't have an item base to send. The target is the machine, and the hold is 0, so it sends it immediately. Now up here, I show the interface name, alter height, alter radius. These we will use in the important network response. So this public static means it can be called from anywhere and it doesn't need an object to call it. Network interface response, handle network command, the player, and the network interface command. Now this network interface command is essentially a combining of all of this information into one object. So if we go through here, the machine is the network interface command target. So if we look at the NIC, so we have command, drag slot, hold period, ID, interface name, all of these objects are now in that NIC object. So the key is the command, which is this right here. This is the key. Now we go through here and I pull an if chain on all these keys, and then I call after parsing the payload. So if it's alter height or alter radius, I know that data, I know that information, the payload is an actual number. But you have to pass things in this interface, you have to pass them as a string. Everything gets passed as a string. So those objects, that number is actually a string that's come through. So the int try parse essentially just says convert that string into a number. If it works, then give me the data. If it doesn't, just set it to 1. That's just kind of a fallback. And then the alter dig state, here's your, I machine it and I payload it. I send it the payload right away. I don't need to worry about converting any of the values. And then I return new interface response, and that just creates a new object. I could do the same thing like this, network interface response, temp stuff equals new network interface response. Then I could do temp stuff dot entity equals segment entity machine. This casts the machine as a segment entity, which all machines are. Then I say inventory. Let's see. Oh no, I need to set temp stuff dot inventory equals to player inventory, even though this is really not required, like that. And then I can just return temp stuff like that. So all this code here is replaced with just this little simple interface. So it's just a really kind of quick and dirty way of returning that information and automatically setting all the variables. Now we get back to our main class. We have to tell the game that UI manager exists, and we need to be able to hook into the window class. So this UI manager network command functions dot add, tell it the window, which comes from this right here, interface name. Tell it the window, and I want a new UI manager dot handle network command, and the MK2 extractor window dot handle network command is essentially sending a delegate into this object to say, I want to be able to handle network commands with this window. And this enables your machine to be able to be edited in game while still communicating with the server. So all of these are set pretty much down the line here. So every time there's a frame, this is called, it goes through here and it grabs the keys. So it goes through here and it says, okay, I want the Q key. If you happen to press the Q key, come in here. And also be aware that because it's called every frame, even hitting the Q key extremely fast will trigger this many times in a second. So I have a command debounce in here, and what that does, it's set pretty low. I think it's set to something like 0.2 or something. Yeah, 0.02 seconds. So it's a very short debounce, but it prevents you from hitting a key just once and having it go up, 20 values and never being able to fine tune it. So if our debounce is greater than 2, which means 0.2 seconds has gone by, then we can go ahead and process it. And I add that debounce into every one of these, and I reset the debounce after the command is initiated. So I never really process too much at once. So every key has to be hit. So your alter dig state has to be hit. Let's see, that's once. This is drop state, so that's once. But then your radius and height have to be done twice because you can go up and down, which are different keys. So this is the key code home and key code end, and that is your radius. And so I capture first if either of the shift keys are held down, and if the radius key is the radius up key or radius down key. And then if the shift keys are held down, I modify it by 10, and then I modify it by 10 here. And the height is the same way. So the height processes this command right here, prevents it from going up too high. Okay, so it doesn't really go up to the, it doesn't go into the millions. There's a ceiling to it. So that is the commands. And then after a command, you just force a GUI update and that kind of refreshes everything, and it's all good. The mark dirty delayed marks it to get marks the whole game to process updates, maybe sync up with your backup saves and make sure the segments and stuff are all in line. And so here, finally, after all that processing, we finally create the text that shows. And this shows MK2 Auto Excavator V with the mod version. And here's my /ns. So the total block scanned, the percent scanned, total power versus max power, the clear ore mode, so that's the excavate state, the drop mode, which is the drop state, and this is automatically to string. The home and end radius shows you the home and end. The numpad plus and minus shows you the height. And then we set the pop-up text and we return the text after that. So this was an exercise in showing and giving feedback to the player as they play and being able to interact with a machine while keeping it server friendly. This window situation here with the network commands is vital in making sure your mod is network friendly. So create a constant string for all of your interfaces and then process the final network interface response, not forgetting to add the UI manager network command functions. This is the next one that you really want to be able to do. So that will do it for this episode. I hope that helped somebody. Let me know if you want some clarification or some more information. But I thank you for watching, and I will see you next time.